Hello. Thank you for joining us today. My name is Derek McKenzie, and I am the Senior Engineer here at MSI. On behalf of our team, NEA, the Northwest Energy Efficiency Alliance, and Swegon, we want to welcome you to this educational series on very high efficiency dedicated outdoor air systems, or VHE DOAS. Today, we will be covering various aspects of the Swegon Gold RX VHE energy recovery ventilator as part of this high efficiency dedicated outdoor air system. We will be discussing equipment components, design considerations for code compliance, as well as controls programming and equipment maintenance. We hope you find the information educational and an overall benefit to your project success. What is a very high efficiency DOAS system, and what components can typically be associated with the design? DOAS starts with a very high efficiency energy recovery ventilator, known as an ERV. Example is the Swegon Gold RX ERV here. The VHE DOAS system also includes a high efficiency heating and cooling system working in conjunction with the high efficiency ERV. Example of that type of system is refrigerant-based electric heat pump delivering dedicated heating and cooling to each zone of a building. This provides ideal comfort at the individual zone level while also remaining extremely efficient. Real case studies by the Northwest Energy Efficiency Alliance, or NEA, have shown that very high efficiency DOAS systems are capable of producing 69% HVAC energy savings and 48% whole building energy savings over traditional packaged rooftop systems. What are the basic design principles and benefits associated with VHE DOAS systems? A VHE DOAS system starts with right-sized equipment to deliver ventilation air, heating, and cooling to the building. The ventilation efficiency is achieved by only delivering the amount of dedicated outside air necessary to meet the occupant ventilation requirements by code. These smaller airflow amounts result in smaller building ductwork, smaller air distribution equipment, and in conjunction with the very high efficiency energy recovery ventilator of the Swegon Gold RX ERV yields tremendous savings to the life cycle cost of the building. This calculated amount of dedicated ventilation air is delivered to each zone individually at what we define as neutral air temperature, typically in the lower 60-degree range. Each zone is then heated or cooled depending on its unique load in the zone by the terminal unit located in that zone. This terminal unit recirculates the air in each zone and is decoupled or separate from the outside ventilation air of the ERV. Examples of terminal units can be various types of fan coil units or active chill beams. This decoupled system greatly increases HVAC efficiency as well by right-sizing the zone equipment to each zone load. Keeping each zone independent increases building indoor air quality by not recirculating air. Dedicated outside air is delivered to each zone, then returned to the ERV for energy recovery and exhaust outside the building. What types of projects and owners are benefiting from VHE DOAS systems? Codes at the city and state level have various performance requirements associated with the efficiency of the building HVAC system. Swegon's capabilities of delivering high-performance units in the form of meeting a fan energy usage of, say, 0.5 watts per CFM, for example, or sensible recovery effectiveness of over 80%, allows us to meet codes like C406.7 of the Washington State Energy Code or local City of Seattle codes. Many government entities are beginning to enforce building performance standards or have sustainability goals that include LEED Gold, Net Zero, or Living Building Challenge, all included capabilities of the Swegon Gold RX DOAS units. The VHE DOAS system has a wide range of applications. We've had experience in the following categories: K through 12, higher education, office buildings, emergency services like fire stations and 911 centers, even healthcare. We recently did a multifamily project where a third-party evaluation was done on VHE DOAS versus standard DOAS systems. This evaluation showed substantial savings with the VHE DOAS systems in regards to the building EUI over a standard DOAS system. Who is Swegon? Swegon's roots reach back to 1932 in the ventilation market. Through the years, Swegon has had a history of producing equipment and components meeting very high efficiency DOAS system requirements that we know today. These components include energy recovery ventilators, active chilled beams with integrated demand control ventilation, and industry-leading refrigerants in their blue box air source heat pumps. Swegon has 16 production plants globally. This includes establishing their North American manufacturing headquarters in Toronto upon acquiring a long-standing HVAC company called Vibroacoustics nearly 10 years ago. Swegon manufactures tens of thousands of high-efficiency energy recovery ventilators for DOAS systems each year, reaching nearly $1 billion globally in HVAC sales. How does Swegon view itself in the marketplace? Swegon's mission statement, feel good inside. We consider ourselves a partner for indoor environment solutions that work precisely to deliver heating, cooling, and ventilation needs at the lowest possible life cycle costs. In regards to sustainability, Swegon considers themselves a key enabler for success today and into tomorrow. We use reductions in operational and embodied carbon through efficiency and recycling. In what ways does Swegon differentiate itself in the marketplace? As an efficiency and sustainability leader, Swegon has acquired many certifications and meet many standards that we use today. Swegon is Passive House certified with VHE. Swegon North America's Gold RX is Living Building Challenge Red List approved when provided with the Declare label. Swegon has many refrigeration developments for air source heat pumps, including Net Zero, pure propane air source heat pumps, and R454B air source heat pumps coming to North America in 2024. Swegon provides chilled beam embodied carbon data in the form of environmental product declarations. For instance, Washington Clean Building Performance requirements can be met with these product certifications and standards. Let's talk about the manufacturing standards of the Swegon Gold RX ERV. The Swegon Gold is designed to be very modular and scalable. The Swegon is available in sizes from 500 CFM all the way up to 18,000 CFM. The units are sectional. The main section, as you see here, includes the fans, the filtration, the energy recovery wheel, and the control system. Other modules are like building blocks on the main section. We can add coils. They could be electric coils, hydronic coils, refrigerant-based coils. We can add dampers. They can be indoor dampers, outdoor dampers if we're going to install the unit on a rooftop. All these sections become plug and play in the Swegon ecosystem. So whatever section we're adding, it's just a building block which we plug into the control system and becomes readily available for control. Let's talk about the environmental impact and construction of the Swegon ERV. The unit is now coated with the magnetless coating that we see here on this door. This is a VOC coating that is designed specifically for harsher environments, completely acceptable to install a Swegon ERV outdoor on a roof next to the ocean. The magnetless material is also very durable and scratch resistant. The Swegon ERV is manufactured with 70% recycled steel. So what benefits do these construction standards provide to the design engineer or the owner over the life cycle of the Swegon Gold RX ERV? Let's talk about installation benefits. The Swegon ERV has single-side access, meaning this unit can be mounted flush to a wall. Ductwork can be either horizontal or we can have all topside connections up to approximately 4,800 CFM. You can also choose between horizontal and vertical as well as a mix and match. Doors are mounted flush, swinging outwards, and providing complete access to all the components of the ERV. As the unit is constructed, it does not require external vibration isolation. In fact, it's not recommended. All these construction benefits allow the Swegon ERV to be installed inside a building and commonly next to occupied areas. Some of the safety benefits of the Swegon ERV are the dual position door handles. One click unlocks the door and releases the pressure. The second click or stage opens the door, allowing access to the internal components. All internal components are on quick mechanical and electrical disconnects, allowing them to be quickly unattached between modules or for removal and service. When looking at the footprint of the Swegon ERV, it is designed to be very compact and extremely quiet. The unit is so acoustically superior, it is commonly installed near occupied areas within a building. It also has extremely low leakage rates. What are the benefits of Swegon fan performance for a VHE DOAS system? Fan energy comprises a substantial amount of energy use in a commercial HVAC system. Swegon fans are mixed flow plenum with direct drive electrically commutated or EC motors. Variable speed EC motors offer the best efficiency in part load applications, demand control ventilation, versus premium efficiency motors with VFDs. Swegon fan design and performance is model specific with accurate fan curves to allow for precise design and system energy conservation. Each fan is dynamically balanced at the factory to ensure its intended performance is met in the field. All fans include integrated, accurate airflow measurement sensors to allow for direct control of airflow in the system. The airflow is adjusted in real time as an example for air density correction, filter loading, and system pressure changes to ensure ventilation comfort is always met. The fans are engineered for strict acoustical performance by attenuating sound and vibration internally. No external isolation is required. All Swegon fans are designed to be serviced quickly by trained staff. Swegon fans are mechanically and electrically connected with quick release harnesses. This is designed to replace a fan with minimal tools in a matter of minutes. With our efficient Swegon fans, we designed to meet stringent energy codes such as the City of Seattle of 0.5 watts per CFM or the Washington State Energy Code of 0.769 watts per CFM. How does the Swegon rotary heat exchanger benefit very high efficiency DOAS systems? The rotary heat exchanger, also known as the energy recovery wheel, are one of the highest forms of AHRI certified sensible and latent recovery in the market. Swegon engineers and manufactures their own energy recovery wheel specifically designed and patented for their energy recovery ventilators. With their turbulent airflow channel design, Swegon can increase the efficiency of their energy recovery wheel by minimizing the pressure drop. The wheel is a single piece of rolled aluminum that is created from the inside and rolled outwards. The wheel design allows for extremely low leakage, which is third-party certified at 0.45% cross-contamination. The wheel also is certified for 0.45% cross-contamination in demand control ventilation applications with our air quality control system integrated to the Swegon ERV controls. The wheel includes a stepless motor, which allows the wheel to control speed down to 0.5 revolutions per minute. To curtail the design for system efficiency, Swegon manufactures 3 differentiating wheel types. There's a maximum pressure efficiency wheel, which is designed to reduce the watts per CFM used in the ERV. There's a standard efficiency wheel, which is a balanced form of energy recovery and watts per CFM reduction. Swegon also manufactures a maximum temperature efficiency wheel. This is designed to obtain the highest possible energy recovery available with a Swegon ERV. All wheels are available in sensible and total energy recovery options. What are the filtration design benefits of the Swegon Gold RX ERV? Swegon's standard configuration includes a MERV 13 filter for optimizing indoor environmental quality. This MERV 13 bag filter provides maximum surface area while minimizing pressure drop. A standard 2-inch pre-filter rack is included for conditions requiring pre-filters in a temporary high-load condition. Examples of those conditions could be construction or remodeling. Perhaps a fire smoke season where a carbon pre-filter is installed in the ERV. Transitional seasons, such as cottonwood seasons, could also be another reason to use a pre-filter. Swegon does not recommend a 2-inch pre-filter during regular operation due to the loading and high pressure drop causing extra energy usage. The Swegon ERV filter construction is very specific. Swegon filter racks are designed for mechanical sealing to properly prevent air and particulate from bypassing the filter media. The rack includes a mechanical lever to seal the filters and reduce leakage to a fractional percentage of the nominal flow rate. I have to mechanically disconnect this filter from the ERV in order to service it. Both the main filter and pre-filters come with pressure drop transducers. They are calibrated at startup, continually monitored, and calculate the adjustments made in order to maintain accurate airflow as the filter loads. This provides optimized building ventilation. The filter points include programmable set points, and they allow the operator to be notified via alarm by the DDC system or perhaps an email server. What are typical defrost control sequence solutions in the marketplace, and how does Swegon provide their defrost solution? Typical defrost management in most sequences are controlled by reading the entering air temperature or the exhaust air temperature. But frosting occurs at a combination of both temperature and humidity. Managing defrost from a temperature-only set point is extremely energy inefficient. Swegon has put out a terrific white paper on defrost management. Let's talk about Swegon's defrost control solutions. Swegon standardizes their controls by measuring the pressure drop across the rotary heat exchanger in real time. Swegon only begins the defrost cycle when pressure begins to build across these sensors, meaning that ice is beginning to form. Upon that, we'll begin a defrost cycle, but otherwise, we will not defrost, which maximizes the energy savings. Typical conditions allow Swegon to fully function without defrost down to minus 5 degrees Fahrenheit when using total energy wheels. So for humidity recovery and hygrostatic rotor control, Swegon offers some very precise control algorithms. Dehumidification reduces cooling loads in high humidity climates. In cold climates, humidity levels are critical to building health, and Swegon can help maintain that humidity by capturing it in the exhaust air and introducing it to the supply air. Some of the highest efficiency buildings may have peak humidity spikes that could benefit from Swegon's hygrostatic rotor control system. For example, during the winter, if showers are used or a humidity spike is occurring in the building, Swegon can actually adjust the energy recovery to minimize the humidification recovery associated with the system, allowing for more sensible recovery load and less latent recovery load. On behalf of MSI, NIA, and Swegon, thank you for watching our educational series on very high efficiency DOAS. Please reach out to your local MSI representative to learn more about our Swegon systems.